Alright, today we're going to talk about levers. Okay, so this is a continuation from Simple Machines. So what are the three classes of levers? So in your lab you either have or will be doing an investigation on three classes of levers. And this is a picture of a very simple lever that you're all used to. And we need to understand what a lever is. And a lever is a simple machine that has a bar that pivots at the fixed point. And that fixed point is called the fulcrum. So if you ever went to the playground and you had the seesaw or the teeter-totter, this is what basically a lever is. In the middle you have your fulcrum. On one end you have your load, okay, or your output force, and the other side you're going to have your effort or your input force. And this other part here, from the effort to the fulcrum, is called the effort arm, okay, and from the load to the fulcrum is called the it says resistance, but it could be called the load arm. Okay, so load arm, from the load to the fulcrum. Alright, so levers are used to apply force and move an object. That force of the object is called the load. There are three classes of levers. So we're going to talk about the three classes of levers and ideal mechanical advantage. So ideal mechanical advantage is mechanical advantage of a simple machine, and it does not take account any friction. Okay, so ideal means the perfect machine. There's no friction, and so whatever we put into it, we should get out of it. That's ideal mechanical advantage. Okay. So the ideal mechanical advantage of a lever is equal to the distance from the input to the fulcrum divided by the distance from the output to the fulcrum. So it's from the input force to the fulcrum divided by the output force to the fulcrum. Okay, and so here's our, real quick, this is our mechanical advantage formula for a lever. Effort arm length divided by load arm length. These are the three classes of levers. There's first class, second class, and third class. And it all depends on where the fulcrum, the load, and the input force is. So for the first class levers right here, the fulcrum is in between the force and the load. So if the fulcrum is in the middle, it's a first class lever. You can think this as a seesaw. That's a really simple one to use for that one. The second class lever, okay, is where the load is in the middle. The force is on one end and the fulcrum is on the other end, so the load is in the middle. This is a good example of a wheelbarrow. Okay? And the third class lever is when the force is in the middle, the load is on one end, and the fulcrum is in the other. Hockey stick, shovel, those are good examples of a third class lever. Okay. So here I have two pictures of levers. Which one do you think is a first class lever? Okay, so let's take a look here. Okay, I'll move my picture out of the way. Okay. And which one's a first class lever? If you said this one is a first class lever, you are correct because of the fulcrum being in the middle. Over here, the load is in the middle. Okay, so this is over here. This is a first class lever because the fulcrum is in the middle. So which one would the load be in the middle? First class, second class, or third class? If you think it's a second class lever, you are correct.